Hi there, and welcome to Mondays with Mike. Today we are talking about the cone of uncertainty. No, not this cone of uncertainty, but the cone of uncertainty that you're going to see so many times this hurricane season that you've probably seen a million times over the years. That cone that gives you an idea, that tells you where a hurricane is expected to go. So today I want to talk about what the cone is, what it's actually telling you, some of its drawbacks, some of the things that are great about it, some of the things that we need to be a little bit cautious about when we rely on the cone. And that's why we as meteorologists will have to sort of make sure that we convey to everybody that the cone is not the only thing that's important. So thank you very much for tuning in this week. So let's get into it. So basically, the cone of uncertainty is very simple. It's the forecast track from the National Hurricane Center. They're forecasting each data point. So 12 hours. So this is where hurricane is, 12 hours, 24 hours, 36 hours, 48 hours, and all the way out to 120 hours, 5 days. But instead of just plotting those dots, they want to convey to you that there is uncertainty. There's error that goes into that. We know that. You're never going to be able to pinpoint an exact location. And so there's a list of errors. Okay. So this is the National Hurricane Center forecast track errors. And then based on those errors, a cone is made. Well, let's start off with the errors. Okay. So if you had to guess how much error there is, in other words, what is the average amount that they're missed, that they missed by in 24 hours. So if you were to make a 24-hour forecast, what is the average error? It's about 50 miles. About 50 miles. When you go all the way out to 120 hours, okay, so 5 days out, if you were to average all of the hurricanes, all of the tropical storms, all of the tropical depressions that have taken place over the last 5 seasons, 2018 to 2022, what's the average error for 5 days out? Well, it's about 250 miles. And so to construct the cone, the Hurricane Center takes and this is where it gets a little confusing, the 2/3 probability, which means that on average, the center of the storm is going to end up in this cone 2/3 of the time. So let me go ahead and tell you, just give you an idea of what we're looking at here. So for example, we're going to use this as an example. This is Hurricane Laura, and this was a big one. This was in 2021. It was a Cat 4 that made landfall in Louisiana. It was pretty vicious. And this is a look at when it was just a tropical depression. Okay, so this is Tropical Depression 13 back on August the 19th, 2020. Did I say 2 years ago? I meant to say 3 years ago. Sometimes, gosh, the years go by so fast, don't they? So this is a 5-day cone of uncertainty. And so when you look at the cone is conveying something very important. So let's say you lived in Florida at this time. If you lived in Florida, you're within this cone of uncertainty. So even though it's 120 hours away from reaching your area, if you're anywhere from Cuba all the way up to Daytona Beach, Florida, that whole area is going. What's up, Rico? No, that's okay. That's Rico Jones here, everybody. There he is. That's the man right there.
Mike Jr.
This is my webcaster.
Yeah, I know that.
But we keep it loose.
Oh,
we keep it loose. We're just, right. I mean, the people want to know. Brittany's over there too, by the way. Okay, so in this case, the cone of uncertainty is conveying exactly what it should, which is if you live in Florida right here, you are alerted to the fact that, okay, we are in that likely area where 2/3 of the time, on average, the center of that hurricane is going to end up somewhere here in this area from Daytona Beach, Florida, down to the western tip of Cuba. So that definitely gives you some pause. You say, okay, well, all right, that's concerning, right? So I'm going to go ahead and move this forward in time, click by click. So now Laura has strengthened to a tropical storm. And look at the end of the cone now. Okay, so now the end of the cone includes Louisiana, includes Mississippi, it includes Alabama. Now all these spots are concerned about that the storm could be headed their way, right? Now, it doesn't mean it's 100% heading there, but it does mean that you're in the cone. Now, I want you to notice where it says 2 p.m. Wednesday here. So if you were to follow just the line, which we never ever want you to do. In fact, this year, for any storms that are coming close to land, we're just not going to show the line because I think it's more dangerous than anything else for people to focus on the line. Or if we do show it, it's going to be really faint. But regardless, I want you to notice here that that center of circulation, the center of that H, is basically New Orleans. Give or take a few miles, it's New Orleans, right? Now, of course, it didn't hit New Orleans, right? So we're going to go ahead in time. 1, 2, 3, 4. Okay, so now we're ahead in time about 24 hours. The center of the cone is still pointed at New Orleans, Baton Rouge area. But notice that cone, which is where the center ends up 2/3 of the time, covers the entire state of Louisiana, covers a little bit of Texas, covers the entire state of Mississippi, as well as much of Alabama. Okay, so this is where folks there in day 4, day 5, near the end of the cone of uncertainty, are starting to make some preliminary preparations. We're not evacuating, we're not doing anything like that, but we're watching, right? We're watching, waiting for each update. At this point, by the way, some tropical storm watches have been put into effect there in Florida as well. So we'll go ahead and move this ahead in time. And notice here how the track has shifted a little bit closer to Texas. Now, at this point, the center of the line is pointed at the Texas-Louisiana state line, Beaumont, Lake Charles. Houston here is in the cone, okay? We're in the cone. Now, does that mean it's absolutely coming here? Of course not, because this cone is pretty wide. Remember, I mentioned that the average error for 120 hours out is about 250 miles. The average error for 96 hours out, which is 4 days, is roughly 150 miles, a little bit more than that. The size of the cone at 4 days out, which would be where it says 8 a.m. Thursday, is 145 miles. So that covers a pretty big area, right? I mean, that covers this area. That's 145 on each side, right? So it covers you from Port Aransas, Texas, to Lake Charles, back over to around Houma, Louisiana. Pretty big area. And then we'll put this ahead in time. So that's where the error is large. So at this point, this whole area here, especially as we look ahead in time, is starting to get very concerned. Now, what I want you to see here is that as you get closer to landfall, and this is what I want to focus in on really more than anything else, as you get closer to landfall, the cone gets narrower. Well, why does it get narrower? Simply because of the fact that a forecast is more accurate the closer you get to landfall. In other words, a forecast for 24 hours from now is much more accurate than a forecast 5 days from now. And so when you look at the forecast errors, it goes from 200 miles to 150 miles to 100 miles down to about 30 miles. So the closer a storm gets to landfall, the skinnier the cone gets. And that's where it becomes a problem. So let me show you exactly what I'm talking about. So as we get closer and closer to landfall here, you'll see that at 10 a.m. on Tuesday, this is August 25th, Tuesday, August 25th, the cone covers an area from Galveston back over to around Vermilion Bay, Louisiana. So a smaller portion of the coastline. And then even if we go ahead a little bit here, you'll see, again, that cone is pretty narrow, okay? I'm going to go ahead and zoom in on it here. Okay, you see that cone is pretty narrow. So we're talking about, it does cover Galveston, it covers Houston, it covers Galveston Bay. The center of the cone is pointed right at Port Arthur, Texas, or Sabine Pass. And then the other side of the cone goes over to, that's around Jennings, Louisiana, is sort of west of Lafayette. Now, why am I focusing on this so much? Because, as I'll show you here in a second, if you were to only look at the cone, then you might look at New Orleans and say, well, we're way out of the cone, right? We don't have anything to worry about. Look how far away we are outside the cone. True, but remember, that's just tracking the center line of the center of circulation. I want to switch over and show you what the storm actually looked like when it made landfall. Okay, here we go. So the storm was very large when it made landfall. Let me move my mug over here. So when it actually made landfall, now we do have the names of the cities on here, at least they're 3-letter identifiers. So BPT is Beaumont Port Arthur Airport. So you see that here right in the middle of your screen, BPT. Houston is all the way over here. Okay, we got nothing. Now remember, we're in the cone. Okay, we got nothing. Why? Because we ended up on the clean side of the storm. But notice this. The storm ended up making landfall a little bit, a little bit on the right side of the cone, a little bit more on the right side here, closer to Lake Charles. But what's important is that the cone does not show you the impacts of the storm. It only shows you the center of the storm and the historical error, the average error to the left and to the right, as well as forward and backward, which I'll explain in a minute. But all it's showing you is where the center is most likely to pass. Now look at this picture. You've got over here on the right-hand side of the screen, you've got Lafayette, Louisiana, you've got around this New Iberia, Louisiana, and you have down here to around Morgan City, Louisiana. So this whole area is getting slammed by rain bands. And remember, you're not in the cone at all. And you're getting heavy rain, flooding, threat for tornadoes, just the whole thing. So the main point to convey here is that the cone of uncertainty is very, very useful. And you're going to hear about this on our hurricane special tonight at 9:30. If you're watching this after the fact, we're talking about May 29th, 10:30 in the evening, and it'll be posted to the website soon, but it's going to run live tonight. And we're talking with Fox Weather hurricane specialist Brian Norcross, and you're going to hear him discuss the cone of uncertainty and the fact that when you're far away from landfall, the cone is really all you're looking at, right? Because, I mean, this storm is 1,000 miles away, right? That's all you're looking at is the cone, because you want to see, am I in that risk area? As the storm gets closer and closer to the coastline, the cone doesn't matter anymore. Or at least it doesn't matter very much, because what you're focused then is, where's the storm surge threat? Where's the heavy rain threat? Am I going to end up on the dirty side or the cleaner side of the storm? And by the way, dirty and clean side just means when you look at this, map, the center of circulation is right here. Okay. Right there in the middle of that, the eye of the storm. On the west side, you're getting much less rain, much less wind, and it's much smaller area. On the other side of the storm, which is over here, you're getting heavy rain bands pulling in moisture off the Gulf, big time flooding threat, big time threat for high winds and tornadoes too. So that's the dirty side of the storm. I have another image I could show you here, which is the satellite. This is the visible satellite presentation of Laura when it made landfall, and what a monster, right? But it's really important to realize that I can annotate here, I think. Yeah, let's see. So the cone, let's see, the forecast track was something like this ish. Okay. So, and I'm probably going to mess this up, but the cone was like this and like this. So if you were to just look at the cone, you would ignore the fact that this part of the storm is the most hazardous. Okay. And then, you know, over here, you're going to have a much smaller area that's a hazard. So anyway, that's just the point I wanted to convey, is that the cone of uncertainty is very important when you are in Texas, in Louisiana, and you are this far out. Okay. Now you're looking at this very, very important. Now you need to plan at this point. Okay. Am I going to have to evac? Do I live in an evacuation zone? You can head to fox26houston.com, by the way, /tropics, and find that out. Scroll down a little bit. Do I have a generator? Do I need flashlights? Do I need batteries? Should I maybe go to the store and stock up on non-perishable foods? That's at this point. But when you get over here, closer, now all of a sudden, okay, that cone is not really that important anymore, because now we're focused on the actual storm itself and where the risks are. So at this point, if you are, you know, west of Houston, you're probably thinking, okay, we're going to end up on the weaker side of the circulation. You know, maybe I could let my guard down a little, but it's very important at this point that you're not in the cone at all. But if you're over there in New Orleans, you've got big problems. If you're over in Lafayette, Louisiana, you've got big problems, even though you're not in that cone. So very, very important. The last thing I wanted to leave you with is this, and that is that when you talk about what the cone is based off of and the errors that I shared with you, that the 2/3 probability error here, 24 hours out is 39 miles. 48 hours out is 67 miles. But here's what is hard to understand. That error is not just left and right of where the storm actually ends up. It's also forward and backward of where the storm ends up, meaning that sometimes the storm goes faster than expected. Sometimes it goes slower than expected. So the error actually is not side to side, but it is actually a circle. So I'm going to do my best here to demonstrate this here for you. It might be a little sloppy, so bear with me, but I was going to break out the whiteboard for you, but then I thought, you know what, it's easier just to use this paint program. So this is what I'm going to do. Let's go ahead. I'm going to say we have a hurricane. I'm going to put the hurricane on the side of the screen under where my face is. So let's say that's our hurricane. All right, we have a hurricane there. Where's the hurricane going? Well, let's say in 24 hours, we think it's going to be over here where the cursor is. Well, in 24 hours, the average error is 39 miles. The probability, what we're going to call the probability circle. So let's say it's this big. So I've now drawn a circle where 2/3 of the time, the center is going to end up in that circle. But now here's where it gets tough. How about a 2-day forecast? Well, now that circle gets bigger. Okay. And I'm going to move it like that. Now that circle gets bigger. What about 5 days out? Let's say we're going to go all the way 5 days out. Well, now all of a sudden it's this big. Okay. So what are we looking at here? It's a bunch of circles, right? Well, guess what? That's what the cone is. It is just a bunch of circles. So if we take this is going to be hard now, but if I take this and whoops, I didn't mean to do that. Sorry. I got too excited, right? I want the pencil. There we go. Pencil. Okay. Now, if I connect these, okay, I'm going to connect these here, here, and here. Now I'm going to connect this here, here, and here. That's your cone. That's what the cone is. And if I were to, try to draw some lines here of where the storm is expected to go, then this is what the center would look like. You see? Do you see that? So that is actually what the cone is right there. Is you say, okay, here's my forecast point for 5 days from now, right here. Here's my forecast point for 2 days. Here's my forecast point for 1 day. That's how the cone is actually made up. So when you look at this, let's say day 3 or day 5 at the end of the cone, what you're actually looking at is a circle. The cone is just made up of a series of circles. So that's actually how the cone is made. And that's how you have to think about it too. So first key is it only is talking about the center of the storm. It's not talking about the size of the storm, how much rain it produces, how much of a storm surge it's going to produce, what the risk of tornadoes is. None of that is taken into account in the cone of uncertainty. It is simply tracking the center of the storm and building up a series of circles to show you how much error there is in the forecast track. And that's it. So, I'll leave you with this. Your question might now be, well, why don't you just show us the circles? And we could do that. It's just that everybody's familiar with the cone of uncertainty, and sometimes trying new things can be confusing. Maybe we will experiment with that this year. I'm hesitant to, because sometimes when you're under the threat of a serious storm, you don't want to come up with too much new, stuff that might confuse people. But maybe we could make some use of that. I'm thinking about it because the cone is just a bunch of circles. Tonight at 9:30 here on Fox 26 or fox26houston.com. Are you ready? It's our 30-minute hurricane special. It is me, along with John Dawson, Ramisha Shade, Lena Maria Arango. We have guests. We have demonstrations. Wait till you see what Lena Maria does to demonstrate how to escape a flood. It's legendary. So anyway, I hope you will tune in tonight. Shout out to Neil and my mom for watching. We will see you guys in about a week. Be down there in about a week. So anyway, thanks for watching, everybody. Remember to like and share and do all of that stuff, because it helps me look good to my bosses. It really does. So see you tonight at 9:30.